Reynolds' experiment was an experiment conducted by Osborne Reynolds for the first time, where he let water flow through a pipe, and in that pipe he injected a colored dye and observed how the color flows through the pipe along with the water flow. So he found that for slower velocities, the color moved in a straight line without getting mixed up with the flow. But as the velocity of flow increased, more and more mixing started to take place, and beyond a certain value of velocity, the color got totally mixed up with the flow. And there he classified the different flows as laminar, turbulent, and transitional flow. That is, when the color doesn't mix up with the pipe flow, the water, and remains a straight line, then the flow can be classified as laminar, and when it gets totally mixed up with the flow, then it can be classified as turbulent. And in between, there is a stage where the color doesn't completely mix with the flow, but the streak line becomes zigzag and starts to mix a little bit with the flow. So that stage is called the transitional stage. So in our laboratory experiment, we'll study the laminar and turbulent flow and transitional flow. So experimentally, these can be classified based on Reynolds number, which is given as Reynolds number equals rho Vd by mu. Rho is density of the fluid, V is the velocity, d is the diameter of the pipe, and mu is the viscosity. And it was experimentally found by Reynolds that below a value of Reynolds number 2000, the flow remains laminar, and above a value of 4000, the flow becomes turbulent, and in between, the flow is categorized as transitional flow. So, and in the experiment, we'll have these kind of observations. In case of laminar flow, where Reynolds number is below 2000, the streak line will be a fairly straight line. In transitional flow, the streak line will become zigzag, curved like this. And in case of turbulent flow, it will be completely mixed with the flow. So how do we calculate Reynolds number? The formula for Reynolds number is this one. Here in the experimental setup, the velocity we have to measure, d will be either given to us or we can measure it directly. Density and coefficient of viscosity based on the liquid used, which will be in our case water, it will be given to us. Now this velocity can be obtained as discharge divided by the cross-sectional area of the pipe. So we first need to find out the discharge through the pipe, and that is volume collected at the end of the pipe divided by the time of collection. So this volume is collected in a measuring cylinder for a known amount of time, for example 10 seconds to 2 minutes about, and that will depend on what is the actual rate of flow. If the rate of flow is very high, then we will have to collect it only for a small time, because otherwise the measuring cylinder will be filled. And if it's a very small rate of flow, then we may have to collect it for a longer duration. Then, how do we actually do it in the laboratory? We'll have an experimental setup like this, where there will be a reservoir. So from this reservoir, using a small pump, we will collect water in a different tank. So this tank will be having a pipe outlet through which water can again flow out, and that water will be again dumped in the original reservoir, so that we can use the same water again and again. To observe the flow patterns, we'll use a small amount of colored dye, that is, it may be potassium permanganate or potash, which is purple in color. So we'll use a small injecting needle which will be connected to a small tank here, and that will be fitted with at this inlet into the pipe. And when the water is flowing out, we can control the rate of flow using this valve. We can partially open or completely open or close this valve to control the flow rate. And to measure the flow, we'll use this kind of a measuring cylinder, which will be graduated in milliliters or liters. So we'll hold this at the outlet of the pipe for a known amount of time, for example 10 seconds, 20 seconds or a minute, based on the rate of flow, and we'll see how much water is collected in that known amount of time, and then based on that we'll find out the discharge, that is volume collected divided by time, and from that we can find out the velocity, which will be discharge divided by cross-sectional area of this pipe. So that will give us velocity, and we can carry out our calculations. So in the observation table for this experiment, we'll have diameter of the experimental pipe given to us. So area of the pipe we can calculate, density and coefficient of viscosity will be known. So first we will note down the volume collected in the measuring cylinder, then the time, and at the same time we will also note down what is the flow based on observation, not based on calculation. So if the streak line remains straight, we'll call it laminar and note down here, or if it is completely mixed, it's turbulent, or if the streak line becomes zigzag, then we'll call it transitional flow. Then we'll conduct the experiment for different sets of discharge by adjusting that controlling valve, and for different flow rates we will conduct the experiments. It will be a good practice if we try to have different values showing all the different types of flow. That is, 2 readings where the flow is laminar, 2 readings where the flow is turbulent, and then 1 or 2 readings where the flow is transitional. And we'll note down these values of volume and time, and at the same time we'll also note down what we physically observed looking at the pipe, and then we'll calculate all these terms, velocity, then Reynolds number, and the types of flow based on Reynolds number. That is, if the Reynolds number is less than 2000, we'll note here that it is laminar flow. If it is between 2000 to 4000, it will be transitional, and if it is above 4000, it will be turbulent. And we'll just check whether this calculated result matches with our physical observation, and we'll put that in the remarks whether it is correct or not. So that's how we conduct this experiment. Historically, when Osborne Reynolds first conducted this experiment, he did it not for 5 or 6 results, he did it for lots of different values of flow rates. So he found that, and for each of those sets of observation, he calculated the Reynolds number, and he found that when the Reynolds number is around 2000 or below, the streak line starts to become straight, and above that it starts to become slightly zigzag, and beyond a value of 4000, he found that the straight line becomes completely mixed with the flow. And therefore, he suggested these values of 2000 and 4000. It's not exactly 2000 or 4000 because we do not have these the tools to find out whether the flow is completely laminar or completely turbulent in those limiting values. But it's like categorizing humans' adulthood, where at the age of 18 you become adult, but below that you remain a minor. So similarly, in case of flow also, pipe flow also, 2000 gives you the criteria of laminar and transitional, and above 4000 it is turbulent. So this was the Reynolds experiment, which you can also perform in the laboratory.